Hello, Algebra 2 students. Today we are going to do section 4.4 notes, solving ax squared plus bx plus c equals 0 by factoring. So notice in this section, the title is different by one letter, and that letter happens to be A. Even though we identified A, B, and C last time in our notes, we will still do that. But last time, in all of our problems, A was always equal to 1. Well, in this particular case, in this section, A is not going to be equal to 1. It's going to be any number other than 1, positive or negative. So when that happens, you have some additional steps. You can't just make the x factor, find the factors, and call it good. So here are the 3 steps that you must always follow when A doesn't equal to 1. Step 1, you look for a greatest common factor. So what number is the largest number that will go into each of those terms? Step 2, you look for special patterns. Is there a difference of 2 squares? And remember, the difference of 2 squares we learned last time, it has a minus sign, and these two are squared. And when that happens, you factor it using the difference of squares pattern. And then the second one, I told you didn't have to remember it, was a perfect square trinomial. You can just make an x factor chart once you have identified that there was a greatest common factor. So you kind of do this in increments. So you can just make an x factor where you do A times C and then B and so on. I guess I mentioned that in part 3. And then you start factoring. However, there's a new thing that you do, and it's this right here. So bubble, and I'll tell you when we're actually doing it. So it's pretty much similar to what we learned last time in 4.3 with an additional one step to do, right? So let's go ahead and factor some expressions completely. So we are going to look at number 1, and the first step 1 is there a greatest common factor? Well, 7, 29, and 4 are not divisible by any number other than 1, and that doesn't count. So we don't have to worry about step 1. Step 2, there is no difference of 2 squares. So at this point, let's just go ahead and make our chart. So in order to make our chart, we have to identify A, which is 7, B, which is 29, and C, which is 4. Make your chart. A times C, B down here, B is 29. So don't just think, oh, I'm going to put 4 there, because it's always A times C. That's why even in the last section, I always had you put the letters A times C. Okay, so 28, when people think of 28, they think of 7 times 4. Well, neither of those added together give you 29, but 1 times 28 is 28, and 1 plus 28 is 29. So here's a case where we actually use the 1. So let's write our factors. Most students think this is what we're supposed to do. So I'm going to think like a student here. So we're going to put x plus 1 Is that correct? Well, first of all, here's how it's not correct. If I multiply these two numbers together, x and x, I get x squared, but we are supposed to get 7x squared. So we know we did something wrong. So that's not going to work. So what does work, and this is one of the new quirks about this type of factoring is, okay, let me erase that. We put a 7 here, because that's what A was. So that's the first thing you notice that's different than just plain old factoring when A was 1. The second thing, and that's the only other thing, is you have to simplify each of those expressions. So 7x plus 1 does not have a common factor. You cannot divide by anything to make it any smaller. But 7x plus 28 does. You can divide both of these terms by 7. It has to be the largest number. It can't be the smallest number. So that leaves us with our final answer. Because remember, 7 divided by 7 is 1, and 28 divided by 7 is 4. Now, let's do FOIL, first, outer, inner, last, and I'll just do it mentally. So 7x times x is your first. and that's 7x squared. So bingo, that takes care of this. 7x times 4 is 28x, and 1 times x is 1x, and added together, that's 29x. And then finally, 1 times 4 is 4. If you do your work carefully, you don't ever have to check it, but that's how you do them. And now we're going to do some more examples, so you just become better at it. Okay, so example 2, you have a 2 is a prime number, 3 is a prime number, and then you have 9. None of those are divisible by anything, so step 1 doesn't matter. Step 2, it's not a difference of 2 squares, so we can go ahead and make our x factor. A is 2, B is -3, C is -9. A times C is -18, B is -3. We've done this one before. I feel like it. Now, and it's not 9 and 2, but it's -6 and a +3. Multiply, give you -18. Added together, give you -3. So we don't want to be like a student who just rushes through this. So since we identify A was 2, we're going to put 2x minus 6 and then 2x plus 3. Now we're going to look at each of the parentheses one at a time. Here I can divide both terms by 2. There I can't divide by anything, so that's x minus 3 times 2x plus 3. And remember, this is the same thing, because I have students asking me, but Mrs. S, I wrote it like this. Well, it doesn't matter. You wrote the same thing, so what difference does it make? So, but I just want you to be aware so you don't panic and look at my answer key like, oh, it doesn't look like yours. So you can write it either way, right? Okay, let's do our next one. Is there a greatest common factor? Not with 5, 18, and 16, and it's a trinomial, so we can make our x factor. A is 16, B is 18, C is 5. A times C, 16 times 5. Don't mess up your multiplication, because if you do, you're never going to find the numbers that belong on the side. And B is 18. Ooh, 80 is a large number, so most people are like, oh, I start at 2 times 40. Well, no, keep going, and you get to like 5, and 16 times 5 is 80, but 16 plus 5 is not 18. So what works is 10 and 8. Key thing is if a number ends in 0, one of the factors is going to be, well, I'm not going to say that for sure. Depending on the number, it could be 10. So 10 plus 8 is 18. So writing our factors, it's be A is 16, so 16x plus 10, 16x plus 8. Now, there's a lot of application problems we do with factoring, so you're probably thinking, well, when are we going to use this? So I just don't think that we will have enough time to do it in the first few sections, but I will incorporate it in some of the others. So when we're doing 2 sections, we're kind of limited on time. Okay, and now the first one you can divide by, okay, so here students are like, well, Mrs. Hess, why can't I divide by 2? Or no, on this one you can divide by 2. So divide by 2, and you get 8x plus 5. On the second one, they're like, Mrs. Hess, why can't I divide by 2? 2 is a factor, but it's not the greatest common factor. So the largest number that's divisible by 16 and 8 is 8. So that'd be 2x plus 1. So you have to think largest. We're always thinking greatest common factor when we're factoring. Never the smallest, but greatest common factor. All right, so for the next one, A is 3. Oh, I didn't even go through the steps. So there's no greatest common factor because 13 and 3 are prime and 4 is not. And there's not 2 terms, so we're going to do x factor. A is 3, B is -13, C is 4. A times C, so that'd be 4 times 3. Okay, so 12 and -13. So this one was one that it took a while for a second. I was like, okay, 2 times 6, neither of them are going to add. 3 and 4, no. And since the top number is positive, the sides here, both numbers are going to be positive or both will be negative. So I tried negative 12 and -1, because negative times a negative is positive 12, and -12 plus -1 is -13. So I'm running out of room, so I'm going to put here 3x minus 12 and 3x minus 1. This one is the second set of parentheses. You can't simplify that any further, but this first one you can divide by 3. So x minus 4 times 3x minus 1. Do a couple of more. Hopefully you're going to get the hang of it with so many examples that we've done. You know what? I'm going to erase this because I got ahead of myself, and that's my problem sometimes. I'm getting too ahead of myself. Okay. All right, for this particular one, look at the numbers. You don't care about the variables. 4, 22, and 10 are all divisible by the largest number, and that number happens to be 2. Now, you don't get rid of that 2, but you write over here, the greatest common factor is 2. What do we do with the 2? We factor it out. So then what goes inside the parentheses? What goes inside the parentheses is, remember, factoring is just backwards, like multiplication. So now it's multiplication backwards. So 2 times 2y squared gives me 4y squared. 2 times 11y gives me that 22y. And 2 times 5 gives me 10. So that's what you do. And when you make your x factor, you don't make it on this anymore. And now you can just cross it out if you want to lightly, so you're not tempted to look at it. You make an x factor for these 3 terms. So we have a times c is, I guess it would make sense for me to identify a, b, and c. A is 2, b is 11, c is 5. So a times c is 2 times 5. And b is 11. Oops. So we can do 10 times 1 is 10, and 10 plus 1 is 11. Funky looking right there. So we don't put 4 because that's why since we have factored out the 2, we're always going to put, this is our a value. So this is our a value. So 2y plus 10, 2y plus 1. And the only terms that reduce are these two. Divide by 2, and you're left with y plus 5 times 2y plus 1. Okay. Getting close to finishing up here. Now, the reason why I wanted to include 6, it's different than all of them because a is negative. We don't like a to be negative when we're factoring ever. So we want to factor out a negative sign. So we want to factor out the greatest common factor for those 3 terms because negative 13 is prime and 3 is prime. You can use the negative 1. We just don't want to deal with a negative number. So factor out the negative 1. And when you're factoring out a negative 1, each of the original terms just becomes the opposite in sign. So that's all you're doing when you're factoring out a negative 1. Just it's the opposite. So everything is going to be opposite. So here, a is 3, b is 13, and c is 4. A times c would be 12, and b is 13. 1 and 12. 1 times 12 is 12. 1 plus 12 is 13. Okay, so that would be, what was a? A is 3, so 3x. It doesn't matter if you accidentally put y when there's x as your variable. I don't care, as long as you know how to factor. So it's 3x plus 1, 3x plus 12. Here, anytime you have a primes, they're not, unless you had a 3 and a 3, then you divide by 3. But here, you don't divide by anything. Here, you divide by 3, largest number. I would never take the time to take all that and use FOIL and multiply it out just to come up with the answer. Oh, I did something wrong on the previous problem and this one. So I need to go and erase it. So I just need to erase that part. And I wanted to show you, we left off a really big step. I did. You never take out the number that you factored out. So that has to go in there, or else you're never going to have a negative 3x squared. Same here. So if I go over here, we go. We have to put in our 2 that we factored out in the original step. I am so sorry. Totally spaced out. But at least you have it now. And you know. So go ahead and put the 2 back there that we factored out, because this always has to go in your answer at the end. And same with this one. There we go. All right. And our last one, this one only has 2 terms, so we cannot make an X factor chart. However, step 1 is there a greatest common factor? And if you notice, -7 and -63 are both divisible by -7. And we want to do negative because we don't want the first term to be negative. So you would divide, well, we don't say divide, we're going to factor out a -7. And then just figure out what would go here. A -7 times a positive 1t squared gives you -7t squared. And a -7 plus 9t gives you a -63t. And then I feel like, oh, I did something wrong again. I'm not even thinking clearly. I'm so sorry. So, the greatest common factor, they both have a t in common. So they have this t squared and a t, so they have at least the t in common. So that's your greatest common factor. So I'm so sorry. So factor out a -7t. So there you have only one t left because it was t squared. And here you already factored out the t, so you're left with +9. You cannot factor any more because the inside numbers in the parentheses have no factor larger than 1. So that is it for that particular problem. Okay, now we're going to do our last 2, which is solving. So remember, when you solve, you must factor first, unless it's already in factored form. Number 1, 17 is prime and the other 2 aren't, so they don't have a greatest common factor. So step 2, identify A, B, and C, and start factoring. So A times C is 15 times 4 is 60, and B is -17. So my students are like, 60 is such a big number to list all the factors of. I go, well, start big. Start with like 3 times 20. Well, 3 and 20 would have worked. So let me just put 3 and 20. 3 times 20 is 60. But even if you did 3 and if you did -20, those two added together give you -17, but those two multiplied together do not give you positive 60. So you just move on, you put more numbers in. So the next ones I did were 5 and 12. And I was like, bingo, 5 times 12 is 60. 5 plus 12 is not -17, it's positive 17. So just make both of these negative. And so those are your 2 factors. So writing our factors, we would have, remember, put A, and just do it in the other one. Make it a habit to just make your 2 parentheses. This one has an equal to 0. And then this would be -5. This would be -12. And now you want to reduce your binomials. The first binomial does not reduce. The second one, you can divide by the largest number, which is 4. And then last step, because it's set equal to 0 and you have the left side in factored form, you can make your little smiley face and use ZPP. Always use ZPP to solve. So we have 4x minus 5 equal to 0, and the other equation is x minus 3 equal to 0. This one's easier, so I'm going to do it. This one is going to take 2 steps. So add 5 and then divide by 4. And there's your two answers. Right. Let's do our last one. So our last one has a greatest common factor, and that is 3. So you can do this a couple of different ways, and I'll show you the way that I'm basically teaching you how to do everything else. So the greatest common factor is 3. So you can factor that out, and you're left with x squared minus 1x minus 3. And how did I get that? 3 times x squared is 3x squared. 3 times negative 1x is negative 3x. And 3 times negative 3 is negative 9. And now you can identify A, B, and C. A is 1. B is negative 1. C is negative 3. A times C is negative 3. B is negative 1. Okay, so negative 3 is such a small number, so this should be pretty easy. Okay, so a negative 3 times 1 is negative 3, right? But added together, you can't get negative 1. So let's do a positive 3 and a negative 1. Those added together give you 2 and not negative 1. So there are no other things that multiply together to give you negative 3. They have to be integers. You can't use decimals. So what the heck do we do here? If you can't find the two numbers. Well, if you can't find the two numbers, it does not factor. So bottom line, does not factor. But that doesn't mean it doesn't have solutions. It does have solutions, but you just don't know how to solve it yet. So let's just write down, we will solve using other methods later. So it does solve. So you can't say no solutions. It does have solutions. It just doesn't factor. So that's what we're going to write there. And those are your notes for 4.4. Have a great day, Algebra 2 students.